Alright students, we are going to talk about simplifying trigonometric expressions, and we have cosecant x cos x plus cot x over secant x cot x. But don't forget that we are not going to use identity on cos x. We will use identities on cot x, cosecant x, secant x. Okay, so let me rewrite the identities. Cot x is equals to cos x over sin x. The identity for cosecant x is 1 over sin x, and identity for secant x is equals to 1 over cos x. I am going to use these three identities to simplify our expression, and the expression is going to be cosecant x is 1 over cos x times cos x plus cot x is equals to cos x over sin x over secant x is equals to 1 over cos x, and cot x is equals to cos x over sin x. I'm sorry, I did a mistake right here. It's not cosecant x, sorry, not cos, it's sin x. It's going to be sin x. Okay, all right, now let's simplify this expression. Cos x over sin x plus cos x over sin x. And now look at the denominator. There is no plus or minus sign between these two expressions, so you can cancel out cos x with cos x. If you have plus or minus, you cannot cancel them out. Okay, now it's going to be 1 minus sin x. Look at the numerator. Numerator have two fractions, and to simplify these two fractions you have to have same denominator. Here you already have same denominator, so what do? You will just combine the denominator, and it's going to be cos x plus cos x over sin x, and here you have 1 over sin x. When you have two denominators, those two denominators can cancel out each other like this. Sin x and sin x cancel out. You will left with only cos x plus cos x, which is equals to 2 cos x. This is the simplified form of the given expression. Here we have another question. Secant x cosecant x minus tan x over secant x cosecant x. We cannot cancel out this secant x cosecant x with denominator, and the reason is this negative sign. Okay, because of this negative sign you cannot cancel out these expression. Okay, we have to use the identities. I hope you remember the identities for secant and cosecant. Secant is 1 over cos x times cosecant is 1 over sin x minus tan x identity is sin x over cos x over. Now you have a denominator. Let's use the identity on this one, and these are going to be 1 over cos x times 1 over cosecant x. If you look at the top part have two same denominators. Sorry, the denominators are not same yet, but you have two fractions, and to make these two fractions, or to simplify them, we have to make same denominator. And to make same denominator, I will multiply this term with sin x in numerator and denominator, so we can have same denominators. Now it's going to be 1 over cos x sin x minus sine x over cos x. Now I'm going to multiply with sine x here and divide with sine x, so we can have same denominators. And here you will have cos x, and sorry, this is not cosecant, this is 1 over sine x. Going to have sine x. Okay, now in numerator we have fractions, and fractions have same denominator. We will combine them, and they're going to be 1 over cos x sine x minus sine squared x over cos x sine x over 1 over cos x sine x. Clear? Now this expression in numerator will become 1 minus sine squared x over cos x sine x 1 over cos x sine x. Clear? As we did in a previous question, cos x sine x, they will cancel out each other, and we will left with only 1 minus sine squared x. Pythagorean identity that we have is sine squared x plus cos squared x equals to 1. I'm going to rearrange this identity, and it's going to be cos squared x equals to 1 minus sine squared x. This identity I will use in the given expression, and it's going to be cos squared x, and this is the simplified form. Now look, whenever you have squared on your trigonometric functions, then most likely that you are going to use Pythagorean identity to simplify our expression. Alright, now we have this expression secant squared x over cot squared x plus 1. Again, as I told you in a previous question, whenever you have squared form, most likely you are going to use Pythagorean identity. Now look, secant squared x is its kind of simple form. I am not going to use Pythagorean identity in numerator, because secant squared x I can change into 1 over cos squared x, because if I will use Pythagorean identity, I am going to have 2 new terms instead of 1 term. That's why I didn't use Pythagorean identity in the numerator. In denominator, I am going to use a Pythagorean identity, which is, I will write it down for you, it's cot squared x, 1 plus cot squared x equals to cosecant squared x. I will use this identity in denominator, and it's changed into cosecant squared x. Okay, now this expression will become 1 over cos squared x over, this will become 1 over sine squared x. This expression I'm going to rewrite in another way around, and it's going to be 1 over cos squared x divided by 1 over sine squared x. Correct? I'm just doing this one this way so you can understand how can you simplify double division sign. When you have this expression, and you remember we used to do this in in a really early classes, whenever you have division sign you can change into multiplication. When you change into multiplication sign, you can flip the fraction, and it's going to be sine squared x over 1. And when you will simplify, this will become sine squared x over cos squared x, and we know the identity that tan x is equals to sine x over cos x. By using this identity, this given expression will become tan squared x, and this is the simplified form of this question. Alright, now this question is a little bit tricky. What is the trick in this? Instead of using identities directly in this expression, like identity for cot or cosecant, I will prefer to take cot x in this expression as a common factor. And when you will take cot x as a common factor, this expression will change into cot x, and you will left with 1 minus cosecant squared x. Okay, from this term and this term I took cot x as a common factor, and you will left with 1 minus cosecant squared x. Now I hope your mind must catch up to this thing, that this expression will use Pythagorean identity, which we use in our question right here. We're going to use this identity, and this is equivalent to cot squared x. Okay, and our final answer is going to be cot cubed x. That's our final answer. But let me make sure the identity we had is 1 plus cot squared x equals to cosecant squared x. If you will rearrange, it's going to be 1 minus cosecant squared x plus cot squared x equals to 0, and 1 minus cosecant squared x equals to minus cot squared x. It means we have here minus, and the final answer will have minus cot squared x. I will write it down properly. You will have minus cot cubed x. Okay, that is the final answer we have for this question.